The MasterSeries Building Design Suite. It's made up of several different areas. What it is a collection of our programs all bundled together in a nice little convenient package so that you can go and design buildings. So what we'll be looking at today is the modeling suite, the MasterFrame and the Model Manager and the Wind, with a wee quick glance at the optional finite element analysis. So the modeling is our MasterFrame, is our 3D Model Manager, and our Master Key Wind Analysis. So as you can see, with the MasterFrame and Model Manager, you are using the Building Design Suite for models. We can also import from DXF drawings, from Revit, from Tekla, from StruCAD, and one or two other import sources. And we can exchange those back and forwards in a loop back out to Revit or Tekla. We can also produce GA drawings and solid models of our own inside AutoCAD. And this is the modeling suite, the core of the building design suite. Onto that we can then strap on all our design components. So if we do steel design, we can add our steel design. If we do composite, we add our composite, concrete, timber, and connections. So these are little add-ons you then choose. So you have the core highlighted in red, and then you add in the bits you need onto that. And then finally, you can also then add in exporting of details of RC drawings. This is the front screen of the MasterSeries, and you will find there is no option, no mention here of a building designer suite. There is designer components, but what we want to do is just to go into MasterFrame. That's the first component of the building design suite. And I want to just look at some typical or not so typical frames that have been generated using the building design suite. So multi-story frames, some nice ones there, an unusual two-story building, and this is an FE slab and shear wall arrangement. Another shear core with some concrete around it, and then another multi-story. Industrial type buildings, we're not restricted to multi-story buildings. This building design suite can handle any sort of structure, and you will then see we're also able to do members with surfaces at slopes, and I'm just going to go into this frame. I'll come back to another one in a moment, but I want to just go into this frame so we can review what all we can actually have in the one structural model. Right, I'm going to turn off the grid lines because now that you've seen them, we'll just make the life easier for us, and I'll just turn on 3D. So what I've got is a first floor that's a finite element transfer slab, because if you look carefully you will see that this column is not coincident with this concrete column below. So the superstructure is offset from the substructure. So we're using this FE slab as our transfer slab. We also have concrete ground beams, and I zoom right in, and you'll see I have a timber canopy out front. Well, not a canopy because it's supported in columns, but you know what I mean. A timber structure out front. I have yellow members are my composite beam members, and then my green members are my main steelwork. Structural beams with openings in them as well, all in this one beautifully put together model for you. So that gives us a good idea of the scope of what we can do inside the building design suite. What I'm now going to do is I'm going to look at some of the editing tools to show you how quick and easy it is to edit. And I'm not going to start and do the whole editing process from scratch. I'm just going to pull one of my more obscure shaped buildings in once I find it. That's it. And here we go. And as you can see, grid lines absolutely everywhere. Again, I'm going to turn those off so I don't see them. And initially, if I wanted to just come along and put a member in, that's very easy. We go into Edit, and then we say, yep, I will add a new member. And as we zoom down, the first thing we see is we're in full MasterFrame. We have full MasterFrame editing. We can define a member, and as we're defining it, we can tell it what type of section it is. And I'm going to say this one is a circular hollow section. And initially, whoops, sorry, I went to a W by mistake. That will be a bit heavy. There we go, CHS. And then we'll bring it down as a trial section all the way down to something like a 219. And as you can see, I can snap, and then I can go to another member, and I can do the same again. I also have the full tools to create members along a member, so I can say I want to move up 2.1 meters because I'm snapping at 100 millimeters, or 2.2 if I want, or anything else. See, coming down and up and down, and I'm going to say no, I want to snap up 1.885. Just type it in, and there I go. I have my coordinate at 1.885. And now I could, for example, coming in here, I could snap perpendicular onto that member. I could snap horizontally orthogonal. I could snap over here and then intersect the two. I could do a lot of different snaps, or I could say, yeah, along that I want to go 2 meters up that, and it snapped 2 meters along that member. So I have fantastic editing tools here, and we'll see these in great detail if we put this frame in, say, in the plan view. And I'm actually just going to look at planet level 1. So that's going to show me a flat surface plan. Now, if I wanted to create another member coming out from this one, another one coming out from that one, I'm going to have to work out all my fancy coordinates, or I'm going to have to introduce grid lines. I actually do have grid lines, but I'm not going to worry about them. Do I have a grid line there? Yeah, I do. I'm not going to worry about them, but what I can do is I can say I want to come, and I suddenly get an extension of that member. So I can say I want to come out 4 meters, and there that came out 4 meters. I can say I want to draw this one parallel to that one, so I'm hovering to say parallel. Sorry, escape. I need to set the right first node first. I can say, yep, I want to draw this one parallel to that one. So I've taken those two, and now I've got a parallel. Grab that node. I've got a parallel and a projection. There we go. Parallel and projection, and it's in. And then just finish off the last one. So I can draw any member relative to any other member. It's just so beautiful. So I can come along, and if I wanted to say take an extension along here, that's just coming straight for me. And if I say I want to also take it off here, I can get that intersection point of those, and there I go. I'm now intersecting at that point, and it does it for me. So editing frames is just so beautiful. We don't need construction lines. We just draw is the simple answer. And we can draw things parallel to each other so easily. As you saw, I want to draw, and I zoom in here, and I want to take a member, say, at midpoint, and then I want to make it parallel to this. So there we go. There we go. I've now got it parallel, and it's now parallel to that member. So drawing members has never been easier. It's totally CAD orientated, totally CAD style. You have all your object snaps, you have all your grids, you have your grid spacings, you have tracking points, so you can go tracking. We can even go polar. So let's do polar. and take from here, and I can go, there's 45 degrees, there's 30 degrees, just going through nothing else other than the fact that it was one of the 10 degrees, one of the polar coordinates that I set up. So at 30 degrees, I can say move along 5 meters, and there we go, 5 meter long at 30 degrees, not aligned to any other member in this frame. So that is how simple it is to create members in the MasterFrame component of the Model Manager. Now what I'm going to do is I'm going to open up another drawing and look at what's the second part of generation. In fact, I'm not going to open the drawing. I'm going to import a drawing. So I'm going to go File, Exit MasterFrame. No, I'll not. Sorry. Yes, I want to exit. I don't want to save. That's what I want to do. Exit. Yes, I want to exit. No, I don't want to save. And now I can use my importing, and I can import DXF files, multi-steel, Xsteel, which is really Tekla these days, 3D Plus, StruCAD, and even Revit. And now the Revit is our very, very intelligent system where we can have bidirectional links, and we can re-update the software, re-update Revit, re-update the MasterSeries back and forwards, and any changes we make on either side is reflected in the other. That is a totally different webinar. What I'm going to do is just take a brand new standalone exchange, and I'm going to call it that. Select that file, and it's by default going to be popped in, and it's my link, and I'm just going to take out a couple of letters. So it's a totally new file. We'll not import any FE surfaces, and I'll just say extract. Off it goes. It's found 810 members, and I can now load this frame straight in as my starting frame. And what have we got? We've got our frame. We have got our built up sections. We've got our cell form beams. We've got our steel. We haven't got any concrete or timber members in our frame. It's identified the bracing members as being bracing and put them into separate groups for us. That is so simple, and from there we walk on and start to put some loading on them. So let's put some loading into this. So come into Edit, and it's as good a point as ever, any, to start the next part of the Model Manager. And that is, and for those who are learning the system or want a refresher, we normally just walk down through this list of options. Now, I will probably skip one or two of them as we go along. We've already added in members in a different example, so to do that, we've already got our columns and our properties. I'm straight down into gravity area loading. So using the Model Manager, I'm going to go in and say my defaults, and it will show me initially what my floor levels are, and I'll say yes, turn on the area loading. And now I'm going to say, well, way up here I'm going to go for a dead load of 0.5 because I will have slab separately, and I'll say I have a 200 slab. I'm going to go for a live load of 0.75, and then once I've come down a few levels down here, I'm going to go for a live load of 4, and then just to make it different, 5, 6, 6, 7, and then 4. That's just so we can demonstrate everything, and we'll apply any dead loads on the slopes of the members, and self weight is going to be dead, and we'll have some composite action. So we're now going to put in some composite floors, and we go to our composite data, and we'll say that here at the first floor, the 2.9 meters up, we'll leave everything the same, but we'll go for a profile slab. It's going to be C for composite, and we're going to go for 1 for partitions, 0.5 for surfaces, 0.5, and wet density 2350, and we'll go for a rib deck 20, or sorry, rib deck 210. So we don't need to change anything. Maybe not. I think I'll go for rib deck 80. If you want hollow core slabs, we can put that in here, and we can add in automatically a stiff deck onto that. So I'm going to, that's now automatically on that floor. So coming back out, we don't actually have anything done yet because we haven't told it where the area loading is. We just told it if there is area loading, these are the intensities on these floors. So let's come along and add in some floors. So I'm going to put in some panels, and I'll just slip back here to plane frame, or not plane frame, wireframe. It's just easier. I'll put it in the front view, and I'm going to take, the first one's going to be called first floor, and I'm going to make this in apply mode to be all these, and I want to make it shortest, in fact, so they will all be shortest. So that's the loading done on that floor, and I'll just add another one. If they were all the same, I could just window the whole thing all the way up, but you know, if I want to play around and be more selective, I can do floors at a time. And then I can say, well, actually, I don't want this one, and this one, because I want to do them separately. And that's going to be spanning that direction. As you can see, as I zoom in, the span has been shown with these little arrows. Hard to see. If I change the direction, it automatically, if I decided to make it two-way spanning up there, it will do so, but I'll keep it one-way spanning. And then I'll add another group, and that's just going to be this other level. And obviously I can't get it because I can't see it. There we go. So it's automatically and intelligently, according to the way we're looking at the view, showing me what I can and can't select. And this is going to be, in this case, two-way spanning. And then I'm going to add in another floor, and I'm just going to make this, all of this up here, and that is going to be again one-way spanning, and we'll make it shortest, so they all become shortest. So what have we got from this? And again, I don't want to stay too long in this area because we've got quite a lot to cover still. And this is why we've divided this webinar up into two different parts, one for the modeling and one for the design, which I think is in about 3 or 4 weeks time. What we've now got is different intensities of loading on these different floors, and I can see from my key diagram my different intensities, and naturally this was spanning a different direction. So very, very simple to generate these, and very, very simple to apply. It is a beautiful system, is the simple answer to that. Now, we have done some members as composite, so if I turn off the area loading and turn on the 3D, we will see that the members at these levels are composite and the members down here are steelwork. So we don't have steel everywhere, we have composite in 1 or 2 areas and steel the rest. So the yellow ones are the composite members. And obviously there's no members in there for it to span against, so therefore it has to be steel, it can't be composite. And I think we didn't put anything into that area. So that is our 1 and 2 way loading. Now what I didn't do here, and it's a very, very great tool, is the ability to add in the stiff deck into the frame. It is something that we introduced, a stronger version. This is a more detailed version of the stiff deck than what we had previously. This is a far more accurate, and I can just come along and take a floor and just say in apply mode it's this floor, and just say the deck is 200 and it is what do you call it, 210. So I'll just pop those in again, and this time when I look at it, it's auto selecting all the principal members in the areas for us and making it all stiff deck for us. So this stiff deck is great. It's very, very strong and useful, and allows us to get a far more accurate analysis of the frame. I mentioned earlier about bracing, and bracing is very, very useful. Obviously for the structural component of the building, make it stand up. But from our point of view, bracing also allows us to distinguish which members are used for spanning the floors or the walls, and separately then which ones are used for bracing. So if you can imagine down here in this, if we go to say, well, let's just create all our default zooms and then go up to planet level 1. Obviously these bracing members aren't what the deck is spanning onto, and if you remember when we turned on, it wasn't spanning to them, it was spanning to the principal beams. And if I show the beams, you then see that it's spanning on to these members here and not anything else. Now, just jumping back 1 second, if I suddenly said, well, actually I want this floor to have a higher intensity, if I went into my area loading, and this is the first floor, I could come in and say make a local change and change the intensity of a panel to have, for example, a live load of 7.5, so it's now a totally different intensity. Or I could take that one as well and do the same. So I can add local changes. I could even change the direction locally so that it spans in that direction. So that one was spanning in a different direction, and I've now changed its span. So locally I can go in and override very, very simply and very powerfully any of the local parameters or any of the global parameters. Okay, we've done stiff deck, we've done loading, we've done area loading, we've done bracing members, we've looked at area load defaults. What I want to look at now is just some of my analysis options, and then we'll look at the wind. So if I go into options, analysis options, we can turn on P delta. If we're dealing with timber or even deep concrete, we can have shear deflections, get a far more realistic analysis. For timber, we can also have load duration, and we can have plastic analysis options. We can ask it to make members go plastic. If we tell it where we want the hinges, then if it overstresses, it will automatically redistribute those, forming the plastic hinges. So if we go to P delta analysis, now I'm probably better looking at the whole frame just to make sense, and our frame. We can turn it on and off. We can either use Newton-Raphson or geometric stiffness matrix. We can go for incremental loading so we can view how it's affecting. We can also find the elastic critical load factor, a pure buckling analysis on this frame. We don't need anything else. The MasterFrame will do it automatically. And if we were doing plastic analysis, we could find the load factor of every single hinge if we wanted to do so. So we have very, very powerful analysis options available to you that give you great benefit. Global data, we can automatically apply live load reduction, and we just put in our percentages as we go down from the top. Bang, bang, bang. So first couple of floors will have no reduction, and then 10, then 20, then 30. And it's smart enough to know that this is the top floor of this run. And that live load reduction is used for the columns. So it's like a post-analysis process. And there are two ways of doing it. We can apply it totally or incrementally, and it gives you guidance in the system. So self-weight is also very intelligent. It looks at all the properties of the sections and uses the self-weight from that. What else have we got down here? Load cases. Fantastic. We can create our basic loading cases. We can create more when we get into wind, and we will be looking at wind next. That third component of this holy trinity, the frame analysis, the model manager, and the wind. So let's go and pull in a slightly, I would say, simpler but also more fun file to look at our wind analysis software. So coming back up here, and I have a little wind generation file. So just coming in, what's it look like in reality? It's a steel frame building. I've played around with it to give it one or two little interesting areas. We've got an overhang, and we've got a upward and a downward sloping canopies. I just didn't want to do horizontal canopies in case you didn't believe me. I've got over here a parapet sidewall, and in fact in here we've also got a parapet, a closed parapet sidewall. So do I have any wind loading on it at the moment? Can't remember. Yes, I do. So I'm going to come in, edit, wind loading, and we'll talk about the rest later. I'm going to show you the fancy bit first, and then we'll get into the boring bits, and I'm going to delete all of my wind panels. So now when I say draw them, there's none there. So there's no roof panels generated. So how do we do it? Well, all we do is we say we're going to span horizontally or vertically. We'll span horizontally and just say away you go, and it automatically runs around the frame, takes 30 seconds, maybe a wee bit more, and suddenly gives us what we think. Right, let's get it distinguished into different colors so we can see the different colors for different zones. And we can see if we zoom in here and we rotate slowly, you'll see that we've got our little exposed floor with our parapet around it. And we've got the same here, except we don't actually want this up here. So if I choose this one, I can then say don't close it. So don't close an open sided edge on that one. And away it goes, and that's now correct. If you remember, I said we had a roof canopy, and that's handled separately from wall canopies, from normal canopies. So these down here, this little canopy here, is totally different to this big boy over here. And you can see on these that it's spanning left to right, and I can just come along and say no, I want that one to span that direction. I can choose this canopy and I can say no, I want it to span that direction. And I can easily manipulate everything in this frame. I can turn around and say, well, actually, for whatever reason, I want this one to span vertically, and for whatever reason, I want this one to span at an angle of 45. And there we go. We can just about make out the wee symbol that that one is now spanning at 45. Or we can say auto set, and then pick the member to set the rotation angle from. I can pick that one, and off it goes, and it's going that way to it, but we could do it otherwise. But no, we'll not do that. We'll just do our standard vertical or horizontal spanning of those. So the frame and the model manager and the wind work in harmony together. There's no external forces involved. But those are just panels, and those are done without knowing what to put onto it. And if I look at them, at the minute I have to tell it what the loading is for each wind direction, but I don't really have to. I can come along and go into my wind analysis and say, yes, I want to turn it on. And I'm now going into my maps. And I'm in the UK, in Britain to be more exact. So I will choose somewhere in the middle there, and then I'll say, well, that's Birmingham, we'll go over there. And I'm guessing that might be Coventry. Or I can choose the same. See if I'm right. No, it was the bigger one was Coventry. That must be Nuneaton or something. And get my location. I can also be even more accurate by giving either a national grid reference or an easting and a northing to get us right down to the micro of where this building is in the UK. We can also flick over to the Irish, and we can choose somewhere in Ireland, up where we are based up here in D, and it might be a bit rude if we didn't have Belfast. Well, there's Belfast, and we are just about, probably there. It's close enough. Right on the coast. And we'll see our orientation of our building. Now, I'm not going to go through all the ins and outs again of the wind analysis program. That in itself is another hour-long webinar. Needless to say, we've got the data. We've located our building. Let's get out of here and see what we've now got. Now we've got the panels and the wind analysis. Let's glue them together. Let's display our wind. Let's do the drawing. Let's look at wind direction 1 and see what we've got. And we're not getting anything yet because there's one component missing. There we go. We need to tell it, and we can see for this wind direction, high suction, lower suction, bit of pressure, and then suddenly high suction again from that edge, and lower and we can see the whole, as we go around the structure, all of these worked out for everything that we've done. And I mustn't have kept that off. I apologize. And then we can look at the next direction, and there aren't any more directions, just the one default direction at the moment. So that last component in the wind analysis, well, there's two components actually. If you just turn this off a second, there is wind diagonals. Wind diagonals are great, and they allow us to reduce the loading on the bracing, because that loading is being transmitted from quite a large area. So an individual member carrying wind load has its full wind diagonal of say 5 meters or whatever, but these bracing members are taking that full frontage, and if I ask it what's my X, well, it's about 26 meters by 26, so I'm going to say about 20 meters just to play safe. So if I now just say give me inclined members only, put it in front view, that's all my bracing. I'm going to come in here and say my current wind diagonal is 20. No need to overcook it. It'll give you a considerable difference. I mean 22, 23, maybe a bit more. And I need to go into apply mode. And those members now will take that reduced, and obviously that one and that one are just sloping members. They're not. Oh yes, they're the canopies. Take that out. There we go. And that was the other one. I knew there was two canopies that I needed to remove from that. So they now have that bigger wind diagonal. And now I move down this list quickly, loading cases. So we're going to go with wind and 4 directions, and we're just going to go with standard internal suction and pressure, no dominance. We're going to go for dead plus min, max and min, dead plus live plus wind, have serviceability, and we're going to go for designer's method, and we are going to work with an augmentation factor of 0.15. using ST factors from the UK, and we'll just generate all those loading cases for you. So it's just generated all my loading cases for me. Now, what have I got? Let's look at the loading cases. I have got my basics, then I've got my dead plus wins, and I've got my A5s and my A20s, and that means that during design component it will only design a member for its win diagonal, which makes your design very economical. So what have we left to do? Probably a wee bit of analysis. And if I said analyze, that's going to take a wee bit of time. So there we go. So that's our analysis done on our frame. Now, the one thing I didn't talk about, if you look at this structure, is that it's all steelwork. So let's look at something that is a wee bit mixed, because this is the last thing I want to leave you with in this area, because we're only dealing with the generation of the structure and the model. We're not dealing with the design in its own at the moment. This is one we've used before in a couple of years ago in our demonstrations of generating the MasterFrame. I mean, this is just too basic now to be shown. As you can see, we've got the shear wall. But what we've also done, composite beams and our steel beams and our concrete shear. And one of the nice things we can do nowadays is we can create member groups. So we can create column splices. And the beauty of the column splices, which I've already done, is that it tells us, and if I turn on my nodes, you'll see this and more. So this is our 3 lift columns. And by creating these super members, these column splices, we're telling it that 3 lifts, while designed as 3 different components and analyzed as 3 different components, will always have the same section size, and that's very, very useful. Whereas in this 5-story area, we're going to take the last 2 lifts off as a separate set of sections, and that makes our life very, very simple. So that's our drafting super members, and that's very, very useful. We also have mixed construction. So where we previously had one type of instruction, we can walk in and override in an area and say, no, 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 I want that member to be non-composite. So this was all composite floor, but we've made this one non-composite by overriding it. I could come down and say, that's my slim floor area, so I want to make those different and change that deck in here just to be non-composite. So we have this facility to go in and change around anything we want. So I could turn around and say, give me a third one, and I'm just going to call it Fred. And I'm going to take, in apply mode, this, 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 and this, and change it to be non-composite. And I could change my loading or my shear or my mesh if I kept it as composite. So that's very, very useful to switch between composite and non-composite in a floor. Obviously, if different floors are composite and non-composite, that's very, very straightforward. You do it in that earlier default area. So what was the other trick in this group of 3? Steel and composite design groups. We might have time to look at eccentricities as well, which are fun. So this is different from this mixed construction. This is now telling us that all these beams are going to have a deflection limit set to group 2, which tells us that we're going to use edge beams with only 10 mil live deflection and 40 mil super deflection with 1/360 and 1/250. So the second value is a millimeter limit. The first value is a ratio limit. So we're telling it that these beams are edge composite beams with a different deflection limit to the other members. So we're able to very quickly go in and then obviously set. And we could turn around and say, well, actually we want a minimum depth of section of say 200, and we want a maximum of, if it's a 457, probably 4 480 would be close enough, or just below 500. So that will make sure a 457 can work, but not a 533, and that will automatically drop out for all those sections and keep it nice and shallow. What others do we have? We have our columns, and we can tell it the columns are simple construction. And again, we've set minimum and maximum sizes. We don't want any 152 columns. We want the 200s and above. And we want to work with a slenderness limit of not 180, but I'm happy at a slenderness of 90. It's not that important these days, but some people like to see the slenderness limits in. And different columns, different criteria, main beams, how you want to restrain them. They're restrained only at their ends, but they're auto restrained at incoming members. So this member here will be restrained by this member, and we'll just use the global moments. So we have all this control that's part of this model manager part of the system. And finally, that last little one that everybody forgets about is the beam eccentricities. We can set for particular beams. So for example, we could choose this, and tell it to offset the member to the outside, and that's going to induce an additional eccentricity into the column at design time. And you could even make it different for N2 if you want to be totally warped, but I will keep it. And we can also say it is plus 100 mil. That's for your normal analysis eccentricity, but for your actual beam alignment, we're going to shove it out by another 40 mil as well. And that will induce additional loads during the design process of the MasterSeries. So ladies and gentlemen, that is roughly taking you through all of the areas of the modeling part of the building design suite. What we haven't seen is all of the output. Taking off the 3D might help. We've seen our deflected shapes with our geometry, any torsional loads, and we could show values so we can see if there's any torsional loads on these. And we can also show you your shear forces naturally, so you can do this. And one of the things we're able to do here is to say show major shear, but only show the values. So that would remove, so that's values only. So that's going to give you the shear at either end of a member, in this case quite dense. But now you're getting the shear at either end of a member, which might do for reactions, printing out for design. But you don't need to do that, because the other stage, if we're talking about the building designer suite, at the very other end, we also have the ability to send straight back out in MasterCAD either GA drawings, we can export to AutoCAD, Multi-Steel, StruCAD, AutoPlant, and we can also go back straight into Revit as well, as you saw earlier. And if we were doing a GA export, and I'm just going to take Planet Level 1 very quickly, page layout, there's my Planet Level 1. If I just resize the page to A1, so that's a 1 and 200, and I'm going to ask for the shear forces on beams, and it'll filter down anything below a value of 1, and it should now give me these, and I'm going to have to export this into AutoCAD. Maybe a wee bit fine in the resolution, but we'll see. And that will just come in very quickly, hopefully. So I asked for both the sections and the shearing forces. So there's a beam going from there to there, shear force of 123 and 123, with two beams coming in either side, 99 and 138. So Ladies and gentlemen, I would like to thank you all for attending. So, in summary, single multi-material modeling environment for all types of structures. Trusses, portal frames, multi-story buildings, grandstand, all done using the MasterSeries. As you saw, it's very versatile and can model anything. The nice thing is obviously that you're only learning one system. You're not learning a concrete system and a steelwork system separately, and then having to go to something very primitive to do your timber. It's all in one. And the core programs, as I said, we were looking at was the frame analysis, the model manager, and the wind. Those are the three main core programs of the model manager. And the two that added together with that is the import export of Revit and this word exporting. And then we can add on for those specialist needs FE slabs. In the design we have again one model for all materials. They're all the same style, and we'll see all that when we work, and then obviously these bidirectional links. So I'm just walking through this quickly because it's not that relevant to today. And then in summary again, design, and obviously the exporting results. So what's it get you? One model, saving you time. It's tailored in that you don't need to take the full big system with steel, concrete, retaining, or steel, concrete, composite and timber and finer elements. If you don't need them, you don't add them in. It's a very simple set of interfaces. I'd like to just say thank you very much and goodbye.